product that had been invented in Australia that has a strong affinity for fats, oils and greases. We discovered also from further testing that it was quite good for taking out chlorinated solvents and other waterborne contaminants. We mount it in socks like this, so it's easy to exchange into vessels, and much bigger than this, obviously. This is just a little demo one. And that's good for a whole range of contaminants, including the range of BTEX-N, which used to be the old BTEX, it's now BTEX-N, and other things. That will take out fats, oils and greases to non-detectable levels in most instances. That's how we started, and then as we progressed and we started building a network of customers from that, we found that a lot of customers have inadvertently have issues with maintenance of systems and that, and send slugs through to the filter, which prematurely foul the media. So we started doing research into other products around the world that would suit our purpose for being a pre-filter precursor to our OAG. It stands for oil adsorbent granules. We found this material here, which we import from America. It's a waste product from the textile industry. It has a very strong affinity for fuel oils and oil in general. It's got some really unique capabilities. A 1.5 metre long sock with 150 mil diameter can do 3,000 litres a minute, and it can strip oil out of water at the down to the levels of 3 to 6 milligrams per litre. So it was an ideal foil for us to then go on and polish it. It made our media last a lot longer. We found that we still had gaps, and that was for some of the really nasty contaminants that we're going to talk about today. PFAS wasn't on the radar at that time, but there were other things, metals and metalloids and a whole range of other things that we were looking for. So we kept researching, and then we found a product, we call it H2OPure, and the first design was it's a sheet, thin sheet, 3 millimeters thick, and after we spoke to the inventors of it overseas, we found it had some very unique properties, and it was really a great fit for us. So we negotiated a deal with them, and we can gain supply of that anywhere in the world. We built it into systems similar to this little thing here. It's a plate and frame filter. It operates at exceptionally low pressures, so less than 3 psi or 20 kilopascals to pass the water through. They can be operated under small pumps with solar panels and batteries. It's a very simple system, and it's very easy to use and to maintain. One of the key elements is what we call zero liquid discharge, so that all the water that goes through can be reused once all the contaminants are stripped out of it. At the end of life of the media, once it's spent and it needs to be replaced, we can put an airline on the inlet and purge the water out of it. That serves several purposes. One of them is that it's easier for the operators when the media needs to be taken out. It's a lot lighter. We don't want to take it to a dry material because it may make the the contaminants airborne. So, but it also reduces the cost of disposal because it removes the water from it and makes it much lighter to transport and dispose of. We can get this in one square metre sheets. We can get it in any size that we want, but typically a 1 square metre sheet at 3 millimetres thick will do 10,000 litres per hour per square metre. So we've designed one for a company over in Western Australia, and that will do, it's about 9 metres long, 2 metres wide and 2 metres high, and that'll do 24 megalitres a day. They had an issue with metals in their waste stream over there. The list of contaminants that this material in particular can absorb, toxic metals, metalloids, PFAS in particular is one we're heavily concentrated on, microplastics, naturally occurring radioactive materials, light fraction petroleum-based hydrocarbons. We haven't tested for that, but we did some trials recently, and it was non-detectable, and that was for the whole BTEX N range and the light fractions. PAH is another one, especially in reservoirs or storage dams after forest fires or bushfires. We can get that out to non-detectable levels with this same material. As I said, polycyclic aromatic hydrocarbons including the BTEX range, BTEX N, so benzene, toluene, ethylbenzene, and naphthalene. So herbicides and pesticides also, it removes, radionuclides and microplastics. So it's a very broad spectrum media. If it's a single use for something similar to like PFAS, it's got a very high ratio of pickup, so it lasts a very long time, especially in large systems. The issue with PFAS is the only good place for PFAS is in an incinerator that destroys the molecular structure. They're going to be around for decades, unfortunately. They're now found that it's airborne. They're found it in Antarctica and Tibet. So we have theories on how that's happening, but it's if it's in the oceans and there's wave action, it'll come up as mist, it'll precipitate down, and it doesn't particularly care where it falls, it'll go everywhere. So we think it's going to be around for at least 10, maybe 20 years until, I think the European Union's banning it as of 2030, totally. US EPA, as you may have seen, they've limited certain amounts of PFAS, mostly long chain, and but I think they haven't gone far enough. So we just want it gone forever. That's the main thing, get rid of it. I met with Associate Professor John Lucas, who's from Ventia, a couple of weeks ago, and we talked about the destruction of this material through their facility at Dandenong. And in the discussion, we talked about temperatures and all the rest of it. And there's varying temperatures for various residence time in the actual incinerator. And they range from 800, 900 to 1,000 degrees C to make that bond. Plate and frame filter, very simple device, at least 150 years old, the technology, just for clarifying wines, taking out the fruit and separating it from the liquor. It starts off with just a basic frame, very simple technology, and it has these two heavy plates on either end, and it's tied together with these endless thread screws. And once you put the media in there, which it just sits in like that, and you tighten it up, the large ones come with oleodynamic enclosures, so hydraulic rams for another term, and you need them because they're so big and there's so many sheets in there. So it squeezes down and it creates, I don't know if you can see it on the camera, but there's a sort of a ridge around here, and that's the seal. That creates a seal on both sides, so that as the water comes in, it comes along a small gallery here, and it can only go in between the plate and the filter, and then it crosses over through the filter and exits out the other side. It's very simple technology. I'll quickly open up the plate and frame and show you that there's what we call a gallery on the end here, and that's where the water comes in, and it's allowed to go in and then permeate through the actual filter itself before exiting. Now these filters, it doesn't go sequentially through each filter, it goes through one filter once. We can double filter, and that's by use. The larger ones, not this one, but they have what we call a diversion plate or a separation plate, which sits in halfway between the media. We can use one type of media on one side, and then we can use this on the other to polish. I'll just show a couple of examples of some of the things we can get. This polyester polypropylene filter media, we can get that down to as low as 0.5 of a micron. And this one here, it's a cellulose paper, that is 0.3 of a micron. So we can use that as a precursor to take out anything that's just of nuisance value and leave this to do the job that we want it to do, is to take out as much of the contaminant and last as long as possible. So that's how the plate and frame filter, as I said, it's very simple, simple technology, and there's multiple types of filter. And we're even going to play around with looking at the adsorbent going in there for certain applications. This is the water filter for home use. We had this tested by the National Science Foundation for World Health Organization certification, which it is now certified as a household filter. It's a 4-stage filter that has this technology in it, and it removes nearly all the contaminants you will find that you may find in your water, whether you're on potable or from a facility or on tank water or whatever. But I've got one at home. I've been using it now for 12 months, and I don't taste chlorine, I can tell you. Another issue with this is that if this material is used, we believe that it will significantly reduce the need for chlorine, not using it, but it will significantly reduce because there'll be virtually nothing in the water, so the chlorine should be able to be reduced to sanitize the water. So that's as much as I can give you in short notice, but I'm happy to have questions if you've got any there now.
Hey Bob, yeah, we've got a couple of questions.
Sure.
The first one is, how often does the media need to be replaced?
Well, that depends on quite a number of factors: the volume of water and the amount of contaminant in the water. So if you have historical chemical analysis and the anticipated flow rate, from the analysis we can extrapolate from that how much contaminant will go into the media for the various contaminants. They're all different on their ratios, but yeah, it all depends. If you're talking PFAS in parts per trillion, then this will last a very long time, and it all depends on the size of the system, how big it is. If it's a 100 square metre system or one that's 6.4 square metres.
Yep.
That answers the question.
I will move on to, I see someone's got their hand up. Mark, did you want to ask a question?
Yeah, I did. Thank you. Thanks for that. It's really intriguing, and what I like about it is very simple technology, which always works better in my book. Has this, I can obviously see it's been used for sort of groundwaters and potable waters, that sort of thing. Has this sort of technology been used more for industrial waste or trade waste?
Yes, yeah, that's where we're heading. We've done testing with gas wells for produced water. They have pretty much everything in it: hydrocarbons and BTXN and metals and naturally occurring radioactivity, a whole range of things. And we did tests. We got the results back, and I couldn't believe the results.
So is there much sort of pre-filtering, obviously, because generally trade waste is pretty dirty media, fairly dirty matrix.
Yeah.
Does it need a lot of pre-filtering? Otherwise, what's sort of the fouling issues you kind of have?
Well, I mean, most medias like this, including activated carbon and other medias like that, they don't like fats, oils, or greases in any volume. That's why we're looking at this as a treatment train potentially in certain circumstances. If we're looking at relatively clean water with a PFAS impact or another type of impact, then it may be, as I said, with a separation plate with a different type of media in there, just to take out any settleable or any solids that may, and we can select any type of micron range as a pre-filter, and it can go in the same machine. The technology of the machines are relatively cheap because they're very simple. Yep.
No, that's what I like about this sort of process the most, because certainly when you're looking at, and most of the issues have been with PFAS treatment, is they're usually either pretty sophisticated or really only geared for small flow throughput, whereas this, and generally pretty complex. So customers need something that's generally bomb-proof, really simple, and pretty cost-effective. So, no, it's very impressive technology. Thank you.
Yeah, no,
Thanks,
welcome.
Mark. We've got some questions coming in thick and fast now, Bob. So the
That's all right.
next one, which has been rated, is, are there any restrictions on the water quality that can be treated? For example, is there a maximum turbidity or level of suspended solids? And can the units be used in wastewater treatment? So I think you've answered some of that, but
Yeah, it depends on the quality of the water quality. So from analysis and turbidity and all the rest of it, it all depends. Yeah, the cleaner the water, the longer the media lasts, the less pre-filtration you need. The dirtier the water, the more pre-filtration, and depending on the pre-filtration. We did some grease trap waste, and it was pretty nasty stuff, I can tell you. We couldn't get near it, it was that smelly. But after we'd set up a treatment train using these other technologies to remove the fats, oils and greases and some of the particulate matter, the organics, the gelatinous material that was still sitting in the grease traps, we put it through this material, and we took a jar pre and post, and we had it analysed. And the jar that was pre, you couldn't get your head near it. It was, we had it on the table, it was like 1.5 meters away, and we could still smell it strongly. But once we'd finished with the filtration, the water was crystal clear and there was no odour whatsoever. So there is application for it, but protecting this is the main aim, so we can do the job that we want it to do.
awesome. The next question, Bob, is what is the PFAS level in the spent media? Does that lead to any specific safe handling requirements given the media has concentrated PFAS?
No, and that's why the system that we're designing, it's fully absorbed. These are what we call depth filters. So the PFAS doesn't just accumulate on the surface, it actually goes inside it. And this one here, the media in here is a special media, and it's a three-dimensional, virtually, for want of a better term, a spider's web of a new material. And so as the material, the liquid goes in, carrying the contaminants, it cannot go straight through. It's a tortured or created, there's a tortured pathway through. It can't go through in a straight line. So as it enters, there's these, you can't even see them with your naked eye or even with magnifier. There's fibrils in there that just are integrated through the whole matrix. And so that's the binding area for the PFAS and other contaminants. They bind to that material and it doesn't let them go. You can clean it. You can backwash it with 1 to 4% caustic. We don't recommend it because it creates all other issues for staff. Use it once and get rid of it. That's the best way to do it. And that's why when we're looking to design a system and we want to air purge the line after use, we can use fresh water to push some through after the when the needs to be replaced, so we can flush the line, and then we can also push through some compressed air to purge the line of any other water. But we don't want it dry. We just don't want to go down that pathway of having whatever's in there potentially airborne. Keep it damp, keep it moist.
Okay, hopefully that answers the question. The next one here, I'm not sure who's written this question in. I might need some clarification. It's around using this unit from an ongoing quality control point. So is there a way, the question is written here, how can this system be monitored ongoing as a quality control point? So is there any, I suppose, inline monitoring capability in the unit itself? Is that the question that's being asked here? If whoever...
Yes, it is. Thanks. Yeah, basically, if we were to put this on, I work in recycled water plants. If we were to put something like this on one of our systems, is that we would need to demonstrate that it was actually doing what we said it was doing, and that's sort of not pulling out a filter after a X amount of time and saying, oh, is it still working? Is it not? We would need some assurances ongoing, like, perhaps I think someone else put a question in there, like, for example, a pressure drop across the filter where you know, a change there could indicate it. Has there been any work done on that would allow us to be able to do that kind of implement it in that way?
The PFAS you can't monitor in real terms, in real time. So it's got to go off for analysis. So that's why this product is so important, because it has the ability to absorb a lot of PFAS at very low quantities and produce non-detectable levels in parts per trillion. There isn't. I've been in touch with a number of the scientific groups that produce equipment, and there is nothing in real time that will measure PFAS.
Yeah, sorry, I didn't mean in that respect with like an analyzer. I understand that you can't do that, but like, for example, on our ultrafiltration systems, we have a pressure drop that we sort of monitor across the filter, where if you don't have a drop, then it sort of essentially, it tells you that there are holes in it, and then more things are getting through, so it's not doing what it should be doing. You know, I mean, I'm not having a go at the product, but it's like we've got to take these kind of precautions, because if there was, you know, perhaps there was one faulty filter where there was a big hole in it, and then we're saying that we're getting a particular removal and we're not, does a pressure drop system, would that work? Like, do you know what the drop is across the media?
Yeah, the delta P is under 3 psi to atmospheric at the moment, because we can't get enough pressure to actually do anything with the water post the filter.
Okay.
So that probably leads to the question you were talking about as well, Nathan. So there's a question here, is how does an operator know when the media is saturated and blocked and needs to be removed or replaced? Yeah, do you measure a pressure drop across the filter box? So that's sort of in line with what you're talking about as well, Nathan? Yep,
that's right.
Yeah, that's a question that I put in there. I mean, these filter things are quite good and quite interesting, but from an operator's point of view, is that when do you know when to actually change it? Because all chemicals have a particular substance, or compounds you're trying to move are a substance they're going to add to the actual meter itself. They're going to be captured there. So in essence, the density is going to change, which means that there will be a developed change in flow characteristics across it. So the answer is quite simple. From an operator's point of view, do you rely on online pressure sensing to determine whether it's time to change your filter pad?
That would be the optimal, yes. That would be the way to go. And seeing it's so low pressure, yes, it would have to be monitored, and then set preset the pressure differential transmitter to a predetermined level. That's the simplest way to do it.
Thanks.
So does this I'm just wondering if what you're just talking about also relates to this question as well, Bob, where someone has asked what flow rates can it handle, and is there a large pressure drop as well?
There's not a large pressure drop, and that's part of it. There's activated carbon in there, and there's cellulose and the special fibrils in there. So the activated carbon only serves two basic purposes. One is to keep the actual the material open to flow. It does some absorption and some blocking of larger particulates on the surface in conjunction with pre-filtration. So all we want is the solution with the contaminant in it. So there's certainly a pressure drop given time, and that's measurable.
Does that answer that question? I'm not sure who sent that one through.
Yeah, that answers my question.
Thank you. There's one here around, can the media be cleaned and reused, Bob?
It can. I mentioned that earlier. It can be backflushed with a caustic solution between 1 and 4%, and then, but it has to be then regenerated with deionized water. So you have to flush it through deionized.
The thing is, do you need to replace or remove the filters and take that away to regenerate them, or can you do a CIP in line and do that without dismantling?
Yeah, it can be done as a CIP, and don't have to take them out. And that can be done multiple, that can be regenerated multiple times. But as I said, you've got to forward flush it again once you've back flushed with the caustic, forward flush it with deionized water to regenerate it again. But what you end up with then is a highly concentrated solution of brine containing the contaminants, which then need to be disposed of as well.
Yeah, thanks. Yeah, I mean, and you're right. I mean, the concentrated material would then create another challenge, and that's something process engineers will need to accommodate in their overall installation of this, that they need to deal with the brine concentrate, for want of a better word, and to dispose of it. The other thing is that you mentioned you need demineralized water. So deionized water. So that's another process that needs to be incorporated as well. And so yeah, but thank you.
Thank you. There's some stuff coming through in the chat as well, Bob. So I think sort of leads on from the discussion we were just having. The talk about the disposal of the used media and obviously the waste that's coming through from this process. Can you talk a little bit more about the disposal of the, I suppose, the waste and or the disposal of the media when it gets to a point where it needs to be disposed of?
Yeah, sure. Look, at the end of life, once the delta P reaches its threshold, its level, and indicates that the media needs to be replaced, as I said, there's a number of things we can play around with. We can do is flush it with clean water to purge the system of any contaminants that may be still in the water prior to going through the filter. And then we can purge it with an air line to blow any water through the system and leaving this material and any potential cake moist but not dry. That all goes away to EPA licensed incinerator type that I mentioned earlier. Ventia, I've spoken with them, and they have a facility at Dandenong that can destroy it. It just goes away for incineration.
I've got a question here around the costing around replacing filter media as well. I don't know whether you wanted to talk about that today, Bob.
Well, it all depends on the size of the system. So how much volume of water do you want to treat a day? So the size of the actual system, is it 100 square meters, or is it, just 100,000 litres a day? It all depends on the size of the system. As I said, we can get the sheets made to any size we want. This is just a baby one. This is 200 millimetre by 200 millimetre square, and they go up typically in increments of 200. So 200, 400, 600, 800, 1,000 or a metre, and 1.2 metre square. That's how big you can get these, the actual frame, plate and frame itself. And we can get the material made to that as well, to those sizes.
Yep.
The price varies. Yeah, it all depends on the size.
Thanks, Bob. This next question goes back again to the EPA licensed facility, and do you know whether or not the waste from this, so the actual question says, any information on what the spent media will be classed as within the EPA waste categorisation and disposal pathways? So have they given you a category of how we would classify that at this point, Bob?
No, we haven't, because it's so varied in what we're doing. We don't know, I mean, we're working across a whole range of industries, including a tailings dam for reclaiming gold. So, I mean, to get a classification from the EPA at this stage, if we're dealing with PFAS and toxic metals and things like that, yeah, we would have to get a classification. It would be a high classification, I would assume. It would probably be one of the highest. But once it goes to an EPA licensed facility and they sign off on it, then your liability's gone. And this probably would, it's not going to be us to do that. It's going to be up to the clients, the customers, and they will have to dispose of it that way. But these EPA facilities, as you probably know, very advanced, very stringent conditions, and they have scrubbers on their flue gas, so that they make sure that there's nothing goes out into the environment. This material, because it's all organic, apart from the contaminants, or once the contaminants break down, there's hardly any ash either, because most of it's incinerated, it's gone.
So that probably leads on to the next question here, Bob, and I'm not sure if you've got the information from the disposal facility, but the question is, does true chemical destruction occur in the incinerator or just conversion into something else? So are we looking at basically a change in chemical structure, or are we looking at full destruction of the contaminants?
Depending on what, metals will still be there in some form, but PFAS, once you break the bond, you've destroyed the molecular structure, it's gone.
I'm not sure who asked that question, or if you're still on the call, does that answer that question for you? Hopefully silence. Sorry.
Yeah, yes, it does.
Thank you. There's a question here, are the units locally made in Australia?
Sorry, I didn't catch that.
That's okay. Are the units locally made in Australia?
You actually talk about the plate and frame filters?
I'm assuming so. I'm not sure who wrote this question.
They can be, if it's a special design for a client. Typically, we get them from overseas, because Europe's been making wine for hundreds of years, thousands of years, and so they have the technology pretty advanced over there, and they have large stainless steel units. These particular plates are what we call Noryl, N-O-R-Y-L. It's a high density plastic. We're looking at actually enlarging the gallery here so that the filter media sits further out, and there's a deeper cavity at the back there to capture particulate matter and other contaminants that don't go through the filter. So we would get those made in Australia locally. There's a place down at Seaford that we just got to take them a CAD drawing, and they'll send it off, and we'll get the moulds made, and we'll bring the moulds back into Australia, and they'll be fabricated here. As I said, these frames are so simple. Yes, we can make them here, but at the moment, no, we don't, because we're not engineered, we're not geared up for that at this stage.
Okay, thanks, Bob. I'm just scrolling through just to make sure. Okay, there's another question here. Have you experienced any salinity reduction through the media?
Absolutely, yeah. Yeah, we did some testing on bore water, and it was an over 90% reduction in salinity, which is, we don't want that anyway. We would prefer not to do that, because we'd rather go after other contaminants rather than just salt or sodium.
I'm not sure if we've already answered this one, but I know it could be related to the size of the filters themselves, but there's a question that's sort of been uprated here. What is the highest flow rate of an existing system, and how much could go through a very large plate filter?
Large plate filter, 9 metres long, 2 metres by 2 metres, will take a 1 square metre sheet, and it holds 100 of them. So that's 100 square metres multiplied by 10,000 times 24. So that system would do, starting off with clean fresh water, 24 megalitres a day.
Okay. Sorry, I'm just making sure that I'm capturing, because a lot of the questions are being uprated here. So I'm just going back through them, Bob. Just a moment. I saw one here that we hadn't gone through. Where is it? Oh, have you got any demonstrations running at the moment for wastewater application?
We have done trials with clients. As I was saying earlier, grease trap waste we did. We've done one with an organic matter. I can't say what it was, but they couldn't get rid of it anywhere. They couldn't filter it out. They couldn't get the material out of it. We were successful in doing that. The other one was for a gas producer over in Western Australia that wanted to look at what we were doing, and their issue was, yes, the hydrocarbon which we could get out, but also the metals that were also coming up in the produced water.
Thank you. I think I've gone through all of the questions that have come through. Is there anyone online that wanted to ask any specific questions while we've got Bob here?
Thanks, Rob. Great presentation, and really looks like a promising product. One of the questions I had was, you mentioned that the media actually comes from overseas. So what's the lead time on getting it in terms of replacements, and do you keep stock locally at all for contingency?
Yes, we will keep stock here.
Yep. And
This is the main aim. The product is very easy to make. It's very simple to make. It's very easy. If we could manufacture it here, we would.
yeah, but if it were coming from overseas, what's the lead time on it?
It's under 6 weeks currently with the way transport is. I'm pretty sure everyone's having trouble, as we are. But yeah, we can source it and get it fairly quickly. If we had to fly it in, we'd fly it in, but if not, it'd come by sea in crates.
Yeah.
It's about 6 weeks, 7 weeks.
Thanks.
Well, that was a massive download of information. If thank
It's all
you
up
so
there.
much. Thank you so much for that, Bob. Really appreciate it. I guess from our perspective, from an IWN perspective, and thank you everyone for attending today. As I said, we have recorded this session and certainly can make it available for people if you would like to share it with other colleagues who may be interested. I guess from our perspective, it would be great to know if we've got any interest out of today's discussion to potentially pursue a trial at one or more of our member corporations, and whether or not we would like to do that, whether it's in a wastewater treatment plant facility or a primary treatment facility or something else. If there's sort of been anything that has come to mind during Bob's presentation today. So I guess from that perspective, if you know, if anyone has any particular interest in pursuing some more information, I did see some comments coming through to say that there is interest in getting some more information. And myself and Dean are going to have a bit of a catch up with Bob next week as well. So if there's anyone, as I said, from today that is interested in getting some more information and potentially running a trial to test out this technology, please let us know, and that way we can progress putting together a trial in one or more of our member water corps. Is there anything else we can potentially finish 15 minutes early today to give you back a little bit of time in your day? Is there anything else from anyone that's still on the call before we end today's session?
Just if we want to get in touch with Robert, in case we might think of some applications or some customers or something where this potentially might work well. We've got those sort of contact details that we can get in touch if we need to.
Yeah, sure. Bob, are you happy for me to share your contact email?
Yeah.
Awesome.
Yep.
I will. I'll pop Bob's contact details into the chat, and but as I said, also if you either send myself an email or you can pop something into our inquiries email as well, and you know, we are happy to coordinate potential trials through sort of our normal avenues as well. So I'll put all of those details into the chat, and hopefully we can get something progressed sooner rather than later. So if there's nothing else from anyone today, first of all, I'd like to say a big thank you to Bob. It was really great, and really appreciate your time and thorough explanation and answering all of the questions that came through. Thank you to everyone who has attended today and giving up your lunchtime. And if there's any other questions, just shoot those through to us, either to myself personally, through to inquiries, or you can shoot some questions through to Bob. As I said, I'll pop those into the chat. And if anyone is interested in the video, if you want to share, just let me know as well, and I can make that available to the group. So Thank you so much, and have a fantastic afternoon, everyone.
Thanks,
Leslie.
guys.
Thanks, Dave. Thanks, guys. Appreciate it.
Thanks, everyone. Bye. Bye.